Hello, I'm Ian Johnson. We're Team 16. We're coming to you with a revolutionary heart rate and blood oxygen saturation monitoring concept that merges a responsive web device or web page that works on different devices or across different devices and our IoT device. So with this two-pronged solution, we're providing accessibility, affordability, and a user-friendly experience for vital sign monitoring.
So let's dive into the device. So as detailed in the practical code CBB file, we implement a synchronous state machine and for efficient transitions between states. Equipped with a heart rate and oxygen sensors, this device prompts users for measurements. Data is transmitted based on user configured settings that they're allowed to change. And when it's connected to Wi-Fi, if not, it's stored, and then it will be stored for up to 24 hours, submitting in the same order it was taken in. And on the back end, we have a robust server with Node.js, Express, and MongoDB. RESTful APIs demonstrated in files like getData.js facilitate seamless communication between the IoT device and the web application. Token-based authentication enhances security, and detailed documentation in each endpoint clarifies expected behavior, parameters, and responses.
Moving to the front end, crafted in HTML and CSS, our user-centric interface enhances the user experience, and custom styling in the site with CSS contributes to a visually appealing design. So the user.js file manages the functionalities of user account creation, login, logout interfaces, and account management. The responsive design also ensures a smooth experience, and across the multiple devices that we have, users also have control through user settings.html. So users can easily configure devices, settings such as measurements, on timing and frequency. It's all putting the user in control of their health monitoring experience in general. And our application provides insightful displays display.html where and weekly display.html where we leverage chart.js for graph visualization, also offering users a comprehensive view of the heart rate data and over different time intervals weekly display and daily display.
So just briefly real quick, we're going to talk about how the app.js and db.js, they are the main entry point for our Express and allow us to connect to MongoDB. And then the particle code, as discussed earlier, allows us to connect with the IoT device with webhook configuration. All the user handles front-end, user.js handles front-end functionality, and all the roots and authentication are done through the other libraries. So we've acknowledged that we've utilized a wide range of powerful libraries to help us with this, including with APIs, including things like Mongoose, bcrypt, chart.js, and then the actual sensor library to discuss what we're doing. We want to thank everyone that really was a part of our journey in creating this. And in conclusion, we think that this heart track is not just a monitoring system, it's a holistic approach to health and management, and our commitment to the user-centric design and robust back-end infrastructure really sets us apart from all the other competition.
Thank you.
Thank you.
Thank you.
So this is our particle device. As you can see, that's the particle, and this is the heart rate sensor. And here, when the blue light is flashing, the user has to put their finger on it and get a reading. And as you can see on our screen right there, you can see our heart rate reading, our oxygen reading, timestamp, device ID, and API. That's how our system works, and it'll send it all straight to the website, and as the server has granted access for the published data, and it's successfully been saved in our database.